Hello friends, welcome to this session. Here we are going to discuss quick solutions of All India Cast Test Series JEE Main. I have Test 6 Chemistry paper with me. Let us start with the paper. This is the first question we have, which says arrange the following molecules in order of their boiling point. If we talk about alkanes, these are all alkanes. In alkanes with increase in number of carbon atoms, the boiling point increases. If we have more branching, then the boiling point will be less. So first of all, let's count the number of carbon atoms. In this case, we have 1 carbon atom. Here we have 2 carbon atoms. Here we have 3 carbon atoms. Here we have 4 carbon atoms. Here we have 5 carbon atoms. And here we have 4 carbon atoms again. So in all these cases, the fifth compound have 5 carbon atoms. It has 5 carbon atoms. Hence, it will have the maximum boiling point. Then we can see 4th and 6th both have 4 carbon atoms. Now among isomeric alkanes, that alkane with more branching, which has more branching, will have lower boiling point. So 4th one has higher branching than the 6th one. Hence 4th compound will have lower boiling point than the 6th compound. Then we have 3 carbons in 3rd, 2 carbons in 2nd, and only 1 carbon in 1st. So this will be the order. Let's go through the options. We can see in the second option, the correct order is mentioned. Hence, the correct answer for this question will be option 2. Now, let's move to the next question. This is the next question we have. It says, which of the following is the propagation step in the halogenation of alkane reaction? If I talk about photohalogenation reaction, there are 3 steps involved. Step 1 is the chain initiation step. Step 2 is the chain propagation step. So, what happens in chain propagation step? Considering methane, in chain propagation step, Cl free radical or any halogen free radical will react, give you CH3 free radical plus HCl, and again CH3 free radical will react with Cl2, giving you CH3Cl and Cl free radical. So this is the chain propagation step. If we go through the options, we can see the correct option and the correct answer is mentioned in option 1. Hence, the correct answer for this question will be option 1. Now, let's move to the next question. This is the next question we have. It says, consider following 2 reactions R1 and R2. These are photohalogenation reaction. Now, if I talk about reaction 1 and reaction 2, there are 2 compounds formed in both the reactions. If I consider the chances of formation of P in reaction 1, we can see the probability factor is 3, 3, 6, 3, 9. And the selectivity factor for primary hydrogen or primary hydrogen is 1. So chances of formation of P will be 9. On the other hand, if I talk about Q, the chances of formation will be, there is 1 probability only, and the selectivity factor for tertiary hydrogen is 5. So these are the chances, 9 for P and 5 for Q. If I talk about next case, here we can see we have bromine. In bromine, the selectivity factor for the tertiary hydrogen is 1800 and for primary hydrogen it is 1. So the chances of formation of R will be equal to 1 into 1800, that is equals to 1800, and S will be equal to 9 into 1, that is 9. So we can see in reaction R2, R is the major product, and reaction R1, P is the major product. We can also see the amount of S formed will be in traces, which is mentioned in option 4 that in R2, S is formed in traces amount. Hence, the correct answer for this question will be option 4. Now, let's move to the next question. This is the next question we have. When methane is oxidized by using hot copper at high pressure, a compound X is formed. When methane is oxidized using hot copper at high pressure around 100 atmosphere, it gives us methanol. So compound X is methanol. And when oxidized by molybdenum oxide, it forms compound Y. Students, if I talk about oxidation in presence of molybdenum oxide, the methane will be converted into methanol or formaldehyde. This is compound Y. They're asking which one is incorrect. Let's go through the options. First one is molar mass of compound X is equals to 32 gram per mole. The molar mass of CH3OH is 32 gram per mole. Molar mass of Y is 30 gram per mole. So this is correct. The difference is in molar mass of X and Y is 2 gram per mole. This is also correct. Third statement says molar mass of Y is lesser and carbon is in lower oxidation state as compared to X. If I talk about oxidation state of this compound, this will be -2 + 2, +1 -1, here also +1 -1. This will be 0. If I talk about methanol, the oxidation state will be -1 +1, here it is minus +1 -1, +1 -1, +1 and -1. So oxidation state is -2. So compound X has oxidation state of carbon as -2, compound Y has oxidation state of carbon as 0. So molar mass of Y is lesser, this is correct, but carbon is in lower oxidation state as compared to X, this is incorrect. So this is a false statement. Fourth statement says molar mass of X is higher, but the carbon is in lower oxidation state. This is correct. So the correct answer for this question will be option 3. Now let's move to the next question. This is the next question we have. It says which of the following reaction will give a major product which can show geometrical isomerism. Here we have chlorocyclohexane with alcoholic QH. It will give you cyclohexene. Here we have two equivalents of NaNH2. Here we have cyclohexadiene in this case. In this case, what will be the major product formed? Sedgwick rule will be followed. The major product will be this. And in this case, what will be the major product? Here we have tertiary butoxide. So Hoffman product will be the major product because of hindered base. Out of the given options, only this third one can show geometrical isomerism. Why? Because here we can see, here both the bonds are different, here also both the bonds are different. Because bonds are different, hence it can show geometrical isomerism. Therefore the correct answer for this question will be option 3.